In this video, we're going to talk about triangle similarity, proportional, defining the word, and then how to use similarity theorems to actually prove that two triangles are similar. Let's first start off with the definition of proportional. Proportional means two items have the same ratio. And ratio is a fancy word for fraction, so as long as it has the same ratio, they're in proportion. In order for you to have similar triangles, you need to have proportionality between side lengths. Similar triangles. Triangles that have congruent angles, or congruent corresponding angles, but sides, or side lengths, are proportional. So the angles have to be the same for both corresponding parts, but the side lengths are not, they don't have to be congruent. They have to be the same ratio though. So for example, within two triangles, if one side is twice as big, then the other side must be twice as big as well. It has to be the same exact ratio. Double, triple, whatever it may be. The symbol for similarity is going to be the single squiggly, like that. You often see that appear on top of an equal sign to make a congruent symbol. Just for similarity, it's just that single one right there. We're going to talk about the next three types of similarity theorems that help you prove whether or not two triangles are similar. So you have three options. And depending on the situation, you have to use which ones you decide which ones to use. So for example, the first one, angle, angle. You need two angles in each triangle for this to work. If you don't have those, you cannot use it. Okay. Now what this says is two angles in a triangle are congruent to two angles in another triangle, then the triangles are similar. My question is why? Well, if you have two triangles, and we don't know the side lengths, but I know that this is a right angle, and we'll call this 40 degrees. Okay? There's a reason why there's only two angles represented, not angle, angle, angle. The reason is that if this is 90 and this is 40, that means your total right now for those two is 130. That means this has to be 50 degrees to make that add up to 180. So you don't need to have that third angle. It's unnecessary. You could say angle, 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 but you really only need two here. Okay. If you have two triangles like this, we have angle 80 for C, and 60 degrees for A, and then 60 degrees for F, and then 80 degrees for D. You have corresponding angles, 80, 80, 60, 60. They are congruent. These two triangles are similar. We have to make a similarity statement. It's already started for us. Triangle BCA is similar to triangle blank. This is very important. You have to follow the same order as the initial statement. So B has to have the corresponding angle in the second triangle. So B is here. It's the blank angle. You have to find the blank angle in this triangle, which turned out to be E. That's the first one you write down. Second letter C, that's 80 degrees. Find the 80 degree angle here. D goes next. Here's a visual right there. And then A, lastly, 60 degrees, 60 degrees, F. That third one's going to correspond to F. So triangle E, D, F. So it's not just about the three letters that you need, but you need to have the correct order as well. The second type of theorem is the side, side, side theorem. It says that if three sides of a triangle are proportional to three sides of another triangle, then the triangles are similar. So they have to be proportional, have to have the same ratio. So what you're going to do is you're going to take the side lengths that correspond and check the ratios. If all the ratios, 3 of them, match up, then the triangles are in fact similar. So we're going to have to go with the comparing the two triangles. They're not labeled in any which way that could possibly help us. We're going to look at the side lengths. Start with the biggest. 7's the biggest in this one. 3.5 is the biggest in this one. So we're going to compare those two. I'm just going to divide them. And I chose to go bigger over smaller. Small over bigger will work as well, as long as you do it the same throughout. So I did big over small for the first one. The second one, we'll do the smallest side length, 4 and 2. I did big over small again. Okay. And then one more, we have 6 and 3. It turns out that all of these equal 2 over 1 or 2 if you simplify them. So if you have 3 side lengths in each triangle that are proportional to their corresponding side lengths and they all have the same ratio of 2, then these two triangles are similar. So if you're going to actually write out the similarity statement, now we have triangle JAC similar to triangle blank. So we have to kind of find out, J, where does that correspond to on the other triangle? J is here. It's across from this biggest side length here, 7. So you kind of have to look at the triangles. This has kind of been turned to get that. So J ended up being on the end of 3.5 would be O. And then A is going to correspond to the other side of this. That's going to be L on the side of O. And then C is going to be the last letter left, M. So triangle OLM. Lastly, side angle side conjecture. If two sides of a triangle are proportional to two sides of another triangle and the included angles are congruent, then the triangles are similar. So pay attention to the order here. Side, angle, side. The angle is put in between the two sides for a reason. That's because when you look at it in a triangle, the angle has to be included or in between the two sides. So like for example here, 15 and 12, 60 is in between or included between these two. Same over here. 60 degrees is included between 10 and 8. So what we're going to do is check to see if the angles are correct, or angles are congruent, and see if the two sides are proportional. So first of all, the angles are congruent. So 60 degrees does equal 60 degrees, so we're good there. Let's check the sides now. The bigger side is 10 here, and then 15 here, so we're going to do big over small, and then 8 and 12 will correspond, so that's 12 over 8. And if you simplify this, you get 3 over 2. Divide both these by 5. And divide both these by 4, and you get 3 over 2. And the fact that they're the same means they're proportional, which means side angle side works here. So now we have to write our similarity statement. So PIT, P corresponds to, P is right here at 60, S is 60. So that means S corresponds to P. I is here at the very top after, across from P from 10. That's 10 corresponds to 15 here, so that's going to be E. And then lastly, L corresponds to T. That's the definitions of the similarity statements that allow you to prove that two triangles are similar.